on the milk carton, Elmer on the glue, singing room and reticulum. Room and reticulum. Room and reticulum. Anyway, you make some room and reticulum. We'll make some and we'll make some now. If you want your hamburger cheaper by the pound, go to South America and burn the forts down. Take some cows and grazing and it will pass. You get meat, milk, mudslides, and methane gas. Well, the cows such snippy comments make. Fatty pot roast, stupid steak. Hey, that's my heifer you're talking about. Another case of a huffing mouth singing room and reticulum. Room and reticulum. Room and reticulum. In a way you make some room and reticulum. We'll make some and we'll make some singing room and reticulum. Room and reticulum. A room and reticulum. In a way you make some room and reticulum. We'll make some and we'll make some. A room and reticulum. We'll make some and we'll make some. And reticulum. We'll make some and we'll make some.
So, has anybody heard that one before? We got a yes. Anybody else? So, lecture 7. So Thursday, we'll finish our discussion about making hay. We have an assignment related to that. And then we'll be outside with our cannulated cow. We're going to get dirty, sticking our arms in a rumen and getting to know that rumen fairly well. So, dress with clothes that you don't really care about. Rumen fluid has a tendency to stain and it's hard to get back out. So, and it smells all right. So there are worse smells in the world. But yes, it does take some getting used to. Question: what is lignin? Lignin is a phenolic compound that strings together and basically turns the cellulose hard. So makes that cell wall rigid. So as a plant ages, more and more lignin is put down in that cell wall, and that plant gets more and more rigid. When we talked about hay quality, the softer it is, probably the more digestible it is. That's related to the amount of lignin in there. Lignin makes it hard and brittle. And the more lignin in there, the less it is digestible. So that's probably all we need to know for this class. So, pro tip. So, as some of you are doing this week, join something here on campus. Join 2 or 3. Get to know other people, especially outside your circle. That's what college is all about. Explore new things, try new things. Nothing else. The welding club is fun. So we have your signups for the Monday or Thursday Coster. So everybody can finish and do their second sign up. So stop by after class, stop by next class, stop by in lab. So Chloe and Emma, Emma's not here, but you're ready for Thursday. So there's probably going to be 3 samples. So we got 2 halages right now. And I haven't decided about the corn silage, whether we're going to do that or not. They're trying to open up the other silo. We'll see how that goes. So we'll keep you posted and get that taken care of. So make sure you sign up. Clipboard's up here, and we'll get that posted up on Brightspace, and everybody will know when everybody's supposed to do what they need to do. So last time we ended up comparing the pony to the sheep, the ruminant versus the post-gastric fermenter. But both herbivores would take a different strategy towards cellulose. So if we compare the pony to the sheep, we talk about an passage strategy that goes with the pony, or an extent strategy that goes with the sheep. 2 different approaches to digestion. And these should be in your handout. Did I not pick that one up? Keep flipping through. Do we have it or not? Supposed to get over to pick up stuff this morning. Should go all the way through to digestion. So you should have the extent versus passage handout slide somewhere.
Yeah.
Okay, just checking. So again, so the first one's the pony, the second one's the sheep. First one's the post-gastric fermenter. The second, or the right side, is the ruminant. So ponies are going to do their fermentation after. Their digestive tract is the same all the way up until that hindgut, where that fermentation starts. So they're going to digest, they're going to absorb. So you got the acid wash in the stomach, the base wash in the small intestine. They're going to extract nutrients as best they can. And then when they're pretty much done with it, they're going to hand it over to the microbes, and the microbes are going to generate what they can by fermentation. Sheep, on the other hand, the microbes in their rumen get first crack. So this influences how we feed them in both cases. So fermentation before, fermentation after the digestive tract. So if we look at the passive strategy for digestion, it's about getting as much nutrients as you can per minute or per pound. We're trying to put through as much feed as we can, and we pull out the easy stuff real quick and then get rid of it. The extreme example of this is the panda. Anybody here know about panda diets? What pandas eat? They eat bamboo. They have pretty much the same digestive tract as you and me. We would probably have a lot of trouble making a living on bamboo. So they eat it, they chew it, and they digest like 2 to 5% of it. So 95% or more passes through their body without anything happening to it. They take what little they can, push it through, get rid of it. Anybody ever seen those recycling sorting places where you got people on the line, they got this conveyor belt going, and people are just pulling stuff out? I'm in charge of tin cans, you're in charge of glass, I'm in charge of plastic. We pull out what we want, and the rest goes through. The extent digestion, the one that ruminants use, is about trying to extract a lot of nutrients, maximize the nutrients for each pound of intake. I'm going to take that pound of feed, I'm going to chew it, I'm going to ferment it, I'm going to re-chew it, ruminate it, ferment it, ruminate it, ferment it, ruminate it, beat the snot out of it, and try to extract as much as I can. So once I get it in, there's a lot of things that have to happen. And that's why if our passage rate is about a day, what goes in comes out about a day later. They take 2 days. They take an extra day in that front part of the rumen to beat up on that feed to extract as much as you can. So rumination, lots of chewing. We have a longer fermentation than the horses do, and it's a slower passage rate. Things aren't moving through the digestive tract as fast as they are with our passage animal. So how do we kind of look at this visually? So there's an equation. If we take the amount of intake times it by the digestibility percent, we get the TDN in pounds, total digested nutrients. So TDN equals total digestible nutrients. So pounds times a percent is going to give us pounds. So what side does the horse work on? What side does the pony work in this equation? In order to get more digestible nutrients, The pony is going to focus on the intake side. The more I can get in, the faster I can extract stuff, the more total digestible nutrients I will have. Eat like a horse that got loose in the grain bin. The ruminant is going to focus on the digestibility side. In order to get more pounds of TDN, I'm going to increase the digestibility. So same intake, greater digestibility gives us more pounds of TDN. So two different strategies, two different sides of the equation to get the same pounds of digested material that the animal then has able to use to take care of its needs. Does that make sense? Any questions on that? So both the sheep and the pony have the fermentation. The chemistry is the same. You have the same type of output, lots of acetic acid, some propionate, a little less butyrate, all generated, all absorbed into the intestines, all goes to the liver, and it's processed from there. So the difference is location. The sheep has before the digestive tract. The pony has after. So that fermentation in the pony beats up whatever the horse doesn't want, ferments whatever the horse doesn't want. Cow, on the other hand, the microbes get first crack. And that has advantages and disadvantages. So with our cows, what leaves the rumen, either absorbed through the wall or flowing down the tract, becomes what the cow eats, or what's available to the cow. So basically, they got that slurry in the rumen, the microbes work on it, and then the cow gets whatever's left. So as the song talked about, we talk about a 4-chamber stomach. First part is the rumen. Big part in our lactating dairy cows up to dairy, we're talking about 30 gallon, 40 gallons in size. So we're processing a lot of material. Reticulum, omasum, abomasum. So looking at this is how many are familiar with those 4 parts of the stomach? Heard those names before. Does everybody know what they do? Each of them do. We're going to learn here in class. So as you look at diagrams in this and any other course, note that there's usually something there that's wrong. So you take it with a grain of salt. So looking at this particular diagram, what's wrong with it? No. So if you're looking at a cow's intestinal tract, it's like 200 feet, not 2. But the focus on this diagram is to show us the location and parts of the stomach. So there's an emphasis by the artist on a certain portion, and then we kind of screw up the rest, but we don't talk about that. So digestive anatomy of a ruminant. There are 4 compartments that we'll talk about. All part of the stomach: rumen, reticulum, omasum, and abomasum. And you'll get to touch all of those on Thursday. So lots of different details there. What we need to remember is that we're dealing with something about 30 to 40 gallons in a Holstein. Huge amounts of muscle associated with this. We're talking 150, 200 pounds of material inside that rumen that's constantly churning, moving, mixing. If you had to move 200 pounds all day, every day, 24/7, you'd probably have some pretty impressive arms. So it's a lot of muscle associated with that. There's a lot of different pockets in the system. There's also these grooves where the blood supply comes in, the nerves come in to absorb the material that's being fermented, and also to establish the reflexes and nerve endings that are necessary to make all the different things that this thing has to do happen. So you've got all these great areas where the blood supply is coming in, the nerve supply is coming in to make sure things are happening, make sure that the feed is being processed accurately. So if we look at a cross section, the head of the cow is this way, tail of the cow is this way. We are standing on her left side. So this is a plasticized rumen that they probably took out of a slaughtered cow. You blow it up, at least when I did it, we blew it up, and then you let the air flowing through the system slowly dry it out. Soak it in different chemicals to make that happen. So if we look here, we've got the esophagus coming down, the reticulum, the rumen, the omasum sticking out there on the side. So let's go through it step by step. So Thursday, we're going to be coming in through a cannula that's right about here on our particular cow. Actually, she's a little bit, just her digestive variation, she's probably about a little bit farther back than I'm used to seeing them. She's just a little weird that way, but we all have our natural variations. The first things you're going to feel coming in, you're going to go into the dorsal blind sac. Dorsal meaning of the top or back of the animal. So this right here is the dorsal blind sac. So when you stick your hand in, you're going to hit this shelf. Then you're going to go forward, go around it, and underneath it into the ventral blind sac of or associated with the belly. Ventral belly button is where we're looking. So you've got two blind sacs. As the cow mixes, she's going to squeeze this and it's going to inject all the contents in. Then she's going to squeeze this one. That's going to inject all the contents in. And she's going to keep squeezing, and you have a slow turnover of the feed in, from this perspective, a counterclockwise flow. So you got the dorsal blind sac. If you take your hand in, you work your way forward, you're going to hit a wall right here. The first one you hit is called the cranial pillar. Cranial of or related to the head, so it's toward the front of the rumen. So you stick your arm in there. We're using our right arm. My elbow doesn't bend the other way. So right arm, we come through. We're going to hit that wall. We go up and over it. We're still in the rumen. But if we go over the next wall, so over one with our hand, over two, so going over, the next stop is the reticulum. If your arms are long enough, you should be able to feel that honeycomb pattern in the rumen. If you take your fingers and go like that, you can start to get that animal to ruminate. Well, at least she'll start chewing. The esophagus coming down. We have the entrance from the esophagus. We go down this kind of light area, and then we leave the forestomach, the rumen and reticulum, through the ROO, R-O-O. Reticulo-omasal orifice. What we have in this circle, does anybody know? Between the entrance and from the esophagus and the exit at the roux. Does anybody know what connects those two? Esophageal groove ring a bell for any of you? Got one yes, nobody else? So we'll talk about that in a minute. So the four compartments of the stomach, the rumen. Each of these compartments has different features that are going to increase the surface area to allow for more absorption. So in the rumen, we have papillae, little tiny fingers coming out from the rumen wall. The more fermentation we have in the rumen, the longer they get. The bigger the fermentation, the longer they get, the more absorptive surface area we need. So looking something like this. They tend to be long and flat and rounded on the top. We did an experiment where we were measuring the length of those before the dry period and after the dry period. So you went in there. I made sure that I didn't cut my nails the day before we did this. The easiest way to clip those off is with your fingernails. So you get these little 4, 5, 10 millimeter papillae, and they did some research on those. So we excised those. So you're looking at about 40 gallons, a garbage can in a mid-lactation Holstein. So probably we fill that one right outside the door easily, and we'll try to do that on Thursday. What happens in the rumen? Fermentation is the big thing. We turn carbohydrate, whatever we've got, into VFAs. This is the process of fermentation. In the absence of oxygen, the microbes take carbohydrates, starch, sugars, NDF, and turn it into VFA. You're going to have a lot of absorption, but only limited things. So the only thing we can absorb from the rumen is VFA, volatile fatty acids, the end products of that fermentation, and electrolytes. For those of you who haven't had chemistry before, sodium, chloride, and potassium. So chloride, you can guess the Latin versions of sodium, and potassium are the remnants of those abbreviations. Moving on to the reticulum. Its absorptive feature is called the honeycomb. We have lots of little ridges in there that are going to increase the absorptive surface area, and there's lots of little bumps on them as well, increasing the absorptive surface area. So if you ever had tripe at a restaurant, you've got all the little bumps on there, but you got the ridges going through. So that's what it looks like. I'm going to call I guess unprofessionally, the reticulum is a director. It decides what's coming into the rumen, what's going out, and how things might be managed in that rumen reticulum continuous compartment. So about the size of a football in a cow, and you'll have an opportunity, if you want to reach down and pull out the magnet. We dose that cow with a magnet. That magnet ends up at the bottom of the reticulum, and see what she's picked up in the last few months. Since we did this last November, I think is the last time we dumped her out. So the reticulum, as we've noted already, has the entrance and the exit to the big vat in front of the cow. The end of the esophagus coming in. You got the esophageal groove, and the roux is the exit. The omasal orifice. So it's the hole between the reticulum and the omasum. So reticular omasal orifice, ROO, root. So this is on a baby calf. We did a dissection. We had a waterhead calf, didn't have a full brain, so we did a dissection in class. You can see coming in, we got a hemostat stuck through here. You've got the entrance. I'm not sure which is which anymore. Guessing this might be the roux over on this end, and then you've got the esophagus over on that end. So what happens with the esophageal groove is it forms a tube that goes from the esophagus down to the omasum. And these ridges on either side flex, come up, and close and form a pipe that hemostat is flowing through. So if we talk about a undeveloped or a newborn ruminant, their ruminant reticulum, very, very small relative to the omasum, which is their true stomach, which we'll get to in a minute. And that esophageal groove runs from there to there. So that's closing up that esophageal groove. And it gets to the point where it's watertight. Nothing will leak. So the idea behind this is we take milk coming in, we pipe it down to the small intestine, to the abomasum, the true stomach, because milk is so high in nutrition that putting it through fermentation would be a detriment to the animal. So we use the esophageal groove to bypass fermentation. Normally, this is only around when the animal's in the milk drinking stage, suckling stage. That's what initiates that groove and allows milk to bypass fermentation. Milk bypassing fermentation, calf gets the first crack at the milk, not the microbes. The microbes would destroy all that high quality protein and the lactose and all those other things. So we want that bypass. You can maintain this reflex through adulthood if you keep feeding a cow a bottle. Everybody's heard of Kobe beef in Japan. They use bottles to feed extra supplements to those animals all the way through their adulthood. So I get these mixtures of protein and vitamins and all that stuff. If I can keep that esophageal groove going, it can bypass and cow gets first crack at it, not the microbes. So the reticulum is central to many of the functions that the forestomach does. Rumination. The bolus is formed in the reticulum, sent up the esophagus, rechewed, and comes back to the reticulum. If those of you doing sail watching animals and they're all laying down, you're not running around with a bucket, watch that rumination. You can see the bolus come up their esophagus. They chew it for whatever number they have, and they swallow it again. There's a hesitation, and then there's another bolus coming up. So how do those boluses do-si-do in the reticulum? I have no idea. But she quickly swallows one, forms another, and it comes right back up. Keeps the process going. Eructation. Does anybody know what eructation is? Burping, the removal of gas from the rumen reticulum. This is a highly coordinated process. And if we mess it up in some way, feeding the wrong kind of feed, or if the animal goes down on her side, that process stops and the animal is going to eventually die from bloat because the Microbes don't care about the cow ultimately. They'll keep fermenting, producing gas, and if the cow can't get rid of it, you get a buildup of pressure, and eventually it can't breathe, the heart can't function. So eructation, a complicated series of events that removes gas from the rumen. Then passage. So leaving of material from the rumen and reticulum. The reticulum decides what goes down to the lower tract and what stays back in the rumen to be fermented for. So it's sort of in conjunction with the omasum, but the reticulum is involved in all those processes. So small but busy. Omasum. So the leaves or laminae increase the surface area. So we're looking at a system. You've got this big round volleyball, and you've got leaves all around it. So you have lots of surface area for that material to pass over as it goes down the track. So this is taking the omasum and we're opening it up. You can see all these grooves here that were leaves that form when you close that back up. So the feed slides in those grooves through, and we get a lot of absorption through that process. So flow of digesta is parallel to where those folds are formed. So we're looking at a volleyball to a soccer ball size in a cow. If we empty out the rumen enough on Thursday, you will be able to reach across and feel that on the other side. Relative to other ruminants, our dairy cows have the largest omasums of any of the ruminants. And that's probably because we've selected them to be able to process a whole lot of feed. In order to process that feed, we need a lot of absorption, and the omasum is where a lot of that absorption occurs. So you've got the sieve. It works with the reticulum, decides what goes down the track, what stays behind. So the bigger particles are held back in those grooves or those leaves. The little particles will move on. The idea between the big particles aren't done fermenting yet. The little ones should be more or less spent. All the fermentation we're going to get out of them. So deciding what goes, again, this is that connection between the reticulum and the omasum. And then the real key to the omasum, and this is why it's so much larger, is absorption. You've got, just like the reticulum and the rumen, you've got VFA absorption, you've got electrolyte absorption, you need those charge balancing things to move together, and then you've got water. Huge amounts of water absorbed there. So you've got a lot of liquid, high concentration of water moving down the track. This is an opportunity to kind of concentrate that dry matter and get that water into the body where the cow needs it. So water is not going to be absorbed in the rumen, is not going to be absorbed in the reticulum. And there are good reasons for that, and we'll talk about that in A&P in the spring. But getting that water absorbed at this point is important. So last one, the omasum, abomasum. You got folds that increase the surface area. In this case, the secretory surface area. So the abomasum tends to secrete stuff, not so much absorb stuff. So those folds there to increase things, allow you to stretch things out. So the abomasum is a true stomach. It's just like ours. You're looking at probably 2 gallons in a cow. If you take 2 milk jugs, stick them together, butt end to bottom, that's about your abomasum. You got secretion going on. This is where digestion gets started. So pepsin starts the protein digestion. That's an enzyme defined by the N. So pepsin is protein. N means enzyme. So protein enzyme. You've got hydrochloric acid that kills the bacteria and is going to denature and dissolve minerals, denature protein to get ready for the digestion that will continue, at least we hope, in the small intestine. So one of the important things is that we have enough hydrochloric acid to kill bacteria. Bacteria don't care what the cow is doing. If you don't kill those bacteria, what are they going to keep doing? Keep fermenting, and fermentation produces gas. At this point, we can't get rid of that gas, and potentially DA happens, displaced abomasum, filled with gas, twists and flips. We'll talk more about that in A&P, but we need to kill those bacteria. Those bacteria are a wonderful source of protein. And the more bacteria we can produce in the rumen, the less we have to buy. Yes, sir. Not following you.
Cut it open to do a DA.
Yeah.
Surgery?
Oh, it is. Guess what the holes from? Yeah.
You talking about cannulation?
I don't know. One of the cows down there.
Has a hole on the side?
Yeah.
Yeah, that's called a cannulation.
Oh.
We'll play with that on Thursday. So we'll get to know that better. So any questions on this? I know you've had this in 160, so you got it's important, so we're covering it again. I should have gone in a little bit more detail than you got in 160. If not, I will continue to go in more detail, but these are the names of the parts. Everybody with me? Any questions? If nothing else, you can remember them by the song. So why do we have song related to history? Something about the human brain can remember songs a whole lot longer than other things. Well, it's also the flow and the music and all that stuff. I mean, I have things popping into my brain that happened decades ago, and it's like, where the hell has that been hiding? There's that stupid commercial, you know? It's like, what the hell? So me and my brother go back and forth with the ones we've that popped into our brain recently. And it's like, okay, where is that stupid commercial encoded in my brain? What molecule is that hiding in? So
What's your favorite one that
I-
pops into your head?
I don't have a favorite. So we got a summary slide there that kind of gives you a list of functions and purposes, things that get done. Everybody with me on that one? So get to know that one. So try your letters. Who moved my cheese? Criteria for essentiality tells us what? The sequence of events that occur in nutrition, how substances are evaluated to determine if they are nutrients, the steps required to determine which nutrient is best. D, how to get an answer right on the exam. What does the criteria for essentiality tell us? Take a guess. We're sharing? Is that what we're doing? Okay. So B is the right answer there. How substances are evaluated to determine if they are a nutrient. If they are a nutrient, what do we know about them? How do we define a nutrient? Get to know that answer. Next question. NFC contains what? sugar, starch, cellulose, sugars and starch, sugar, starch, pectin, organic acid, sugar, starch, and organic acid. We're looking for C. What does NFC stand for? Non-fiber carbohydrate. It's the opposite of what? NFC plus what gives you 100 of all the carbons? NDF. So non-fiber, fiber. And SC contains which? Same choices. Looking for the answer B, right? The difference between NFC and NSC is what? Pectin and organic acids, right? One's present in NFC, it is not in non-structural carbohydrates. Any questions on any of that? Speaking of which, we got an exam a week from Wednesday, I believe, in this class. Is that a good day to have that exam, or you got tests all over the place? Okay. We'll get you taken care of. Anybody else have exams that day or haven't you looked?
Talking back one.
Week from Wednesday, yep. Okay, there's an opportunity. Take a look at your schedules. We'll address it again. So vocabulary, talking about digestive function. We need to compare digestion, fermentation, and degradation. You're going to hear all these words used, and sometimes they're used wrong by people with PhDs. Just the way we talk about them. You talk about NDF digestibility. NDF cannot be digested. It can only be fermented. But we talk about whole tract digestibility and things like that. So digestion formally is the chemical or enzymatic breakdown of feed by a cow. The mammal is doing the work in digestion. Fermentation, we're breaking down the feed by microbes, the bacteria, the fungi, the protozoa in the stomach are doing all the work. That required, if it's being done right by our cows, it's fermentation. A generic way of speaking about those two processes called degradation. You'll hear this a lot related to protein degradation in the rumen. We don't care how it gets done, it just gets done. So that is kind of a generic way of saying digestion or fermentation. We don't care. So degrade, degradation, break things down. So on Wednesday, we'll begin with the attributes of the rumen fermentation. I'll spoil the surprise. That's what we're going to talk about. I have a quiz that we didn't get to in lab. So I'm asking you to calculate a dry matter. But I'm not asking you to do the math. I just want you to set it up. Put the numbers in the right spot. Be clear and definitive as to where those numbers are. You have as much time as you want. You're setting up one dry matter calculation.
Here you go, boy.
All I'm asking you to do is set it up. Don't pull out your calculators or anything like that. You want to?
Turn it sideways. So I don't mess you up. Thank you.
When you're done, you're free to go. To make up with you, right?
Yeah.
And so Molly and it's the other one that they need to make up?
Yeah.
Okay, so at some point, can you two get together and we can find a time to make up the lab?
Yeah, can I not do it this week? Just 'cause-
Probably not, probably needs to be early next week to
Yeah.
get the assignment done,
Yep.
but we can find a time, whatever works for you, okay?
Yeah.
Okay.
Do it 14th. Maybe that one, right? Right here, yeah, perfect. I'll show you the picture so I don't forget. Yeah, we can do that. So both you, yeah, it's not kind of- yeah. Thank you. What happened?
Good thought.
What was my ID number? I forgot that.
I think we'll get it.
Thank you.
I think I took a guess. I think I did.
Okay, well, you're gonna see that question again on the test, so make sure you learn it. This is my way of warning you.
I also have a question.
Yeah. Okay. I think I can answer that one.
On the left side, I think.
Now I'm going no.
No.
Yeah, upside down.
Guess I was a little confused at Professor. I'll be studying on that.
Okay, thank you.
I'll see you.
That's the reason we do this. Is that okay here at the end? Is it okay here at the end? Okay, just checking.
Yeah, good. I was just like, oh, like, but.
Okay.
I'm okay on that part.
Yep, this is my study encouragement for you.